Welcome back to the third and final part of the Resident Evil puzzle or rotating puzzle tutorial series. In this part, we're going to finally go over the rotating puzzle part. So we're going to start this off very simply by setting up our inputs, just with a simple print. So the first thing to do to get that working is to add the actual inputs to the IMC that we set up last time right here. In the previous part, we made all the interaction ones that we need, so we don't actually need, or we made all the input actions we need. Now we just need to apply them in the puzzle. So let's go in. So we're going to keep on interact, and I just realized we don't actually need our confirm, because our confirm is essentially the interact button. We're just going to confirm it with that, so we can delete the IA confirm. We don't need it. Next, we're going to add our cancel, so we're going to look for cancel, and for input we will use tab. Usually you'd want to use escape, but escape in Unreal will just close the editor, as in the plain editor mode. So it's kind of annoying, so we'll just put tab for now. For rotation, so rotate, we're going to need here. And we actually need to change it slightly. And the reason we need to change it is because rotation is going to be a 2D vector. And right now, if we go and open it up, it is just a Boolean. So digital Boolean, we want to change this to be an axis 2D and save it. So for rotate, we're going to need 4 keys. So I don't know if we can add 4 for none. Yeah, we can. So first one is going to be W. Second one is going to be S. Third is going to be A. And fourth is going to be D. And open them all up because we need to change some settings here so that they work properly. So in our modifiers here for W, we want to add. And what we are looking for is we are looking for swizzle input axis. So this one right here. And we're gonna leave this as it is. It works just fine. This is essentially to let the system know that it is an axis input, pretty much. For example, it is only necessary on the W because by default it is using the X, and we need to have the Y, which is why the Y is first here in the default. So for the S, obviously being a vertical one as well, we need to also add the same modifier, which is going to be our swizzle. But we also need to add negate because we need to invert it, because this time it is going down, for instance. So when we press S, it's -1. When we press W, it's 1. And because these are on the proper axis, we just need to do the same thing, but negating it. So in the case of A, we want to negate it because it is left. So we're just going to look for negate. And for D, we don't need to do anything because it is already going right on the horizontal axis, so it doesn't need to be swizzled to be another axis. So we can save that, and that does it for our rotation. So I'm just going to collapse these. Next, we're going to need 2 more inputs. First one is going to be grab. So for grab, we need to make a small change, and you can do this 2 ways. So what we need is grab here. We're going to say left click. It's going to be grab. And so what we need to do here is there are 2 options for it. When we want to change our triggers. Now, we could also do this with just start and end, but we're going to do it with the triggers because that's what they're there for. So we want to say on pressed, we want to do something, but we also want to do something on released. So we also want to do released. So both of these. Now, we can do it here, or we could open up our grab here and do it in our triggers here. So this time we're just going to do it here. It doesn't make any difference. It's just that if we were to use grab somewhere else, these are only used in the puzzle grab specifically. And finally, we also want to have the look, because as we move our mouse, we want to know how to rotate if the mouse is pressed. So we have IA look here, and these are ones that should be by default in the project. If you use the template, or a minimum the first person template should have these. So then we're going to look for, not this, we can't actually use a button here. We want to look for mouse XY, and it will give you XY to the axis. And so this pretty much just means as you move the mouse, it will keep its location. We do need to make a slight change though. We want to add a modifier. We're going to look for negate, and we want to make sure we only select the Y. So that does it for all our inputs right here. So let's go and close this, and we're going to add them into here in our pedestal so we can test if they work and trigger when we want them to. So let's start with our, let's just move this, and we'll keep the possession at the top so it's easier to handle. And so we're looking for IA interact. And so we already know this one works. We tested it earlier. We can just double check by adding another print. Then we want to look for IA grab. So IA grab, this time we're going to do print, and we're going to see if it's true or false, depending on if we release. We want IA rotate. It's right here. Actually, we'll just get our IA look first, sorry. So IA look, and we'll just also add a print for the value, so we can test that as well. And we're using, sorry, I didn't mention this, but we're using the triggered for all of them pretty much. And for rotate, the same thing. We're going to look here, print, string, and attach the final one here. Oh, I'm forgetting one. We have cancel as well. So this one is just a normal print untriggered. I think cancel might actually not be, I think we might change it so that it's pressed. I think it's going to need that, otherwise it will spam it. So change this trigger to be pressed. There we go. So let's go ahead and let's just put cancel here for that. And for this one, we will say interact, or actually confirm, because that's what it's for. Let's go and play. So right here, if we press our left click to drag, it doesn't do anything. Our looking isn't printing anything. But if we now interact here, it's going to start, as you can see, I'm moving my mouse here. It is considering it as positions that it moves. If it's not moving, it will stop printing because it's not being triggered. If I left click, it says true because I just pressed it. If I release, it says false. If you press tab, we get cancel. And if you press F, we get confirm. So all the inputs are working. Let's now get into make them do what they need to do. So before we go into all the complicated stuff, I'm going to start with all the variables. First things first, we're going to add a few variables. We're going to add a solved. So we'll call is solved. And so this is pretty self-explanatory. If the puzzle has been solved, it's solved, and we don't want to interact with it anymore. So I'm actually going to do this very quickly. We have an ignore interact. If it is solved, we ignore interaction. There we go. So this shouldn't, if we run a test and right now play, we can still interact with it. It still works fine. Now, if this gets set true when we solve it, that won't work anymore. So next thing we need is another one, and we will say is valid position. Is valid rotation, probably. It's better. Is valid rotation. We'll simply check when we try and rotate our puzzle piece. Does it line up? Yes. This becomes true. We press confirm. Puzzle is solved. Now we need one final one, which is mouse down, which is just to check if we are dragging. Otherwise, we would have it when we're constantly moving, and we don't want that. Next is the float. So for the float, we're going to have a tolerance. So let me just change this to float, not into the float. So what this one does is very simple. As we rotate our cube, the tolerance will be able to say, oh, do we want to be like 1 unit close for the rotation and we consider it okay, or do we want it to be 15? So it's a lot easier to align it up even if the shadow isn't perfect. So that's kind of used here, so you can change your parameters with how you want it to move. Same thing for the next one, just duplicating. We're looking for sub step, which is just how quickly you drag the item pretty much. And finally, one last one, which is the target rotation, which is just this rotation you want your actual cube or puzzle to be considered solved. So we're looking for rotator like this. And in this case, we want these 3 here to be exposed, not exposed, instant editable, so that each puzzle can have its own rules if you would like. So right here, we can change our tolerance, our substep, and our rotation for each puzzle that we have. Okay. Now, next, we have a few extra things. So we have our previous pawn, and I'm actually going to put this in a category, which we'll call pawn for now. And inside it, we're going to need another UI. So I'm going to actually, for some reason, it didn't duplicate. There we go. And it's going to be called instruction UI. Now, we don't technically, well, actually, we do need to save it because we need to delete it later. So, but we don't need any information for it. So we're going to look for user widget here. Even though we haven't created it, we know it's a child, or we are later going to make a user widget child, so automatically this is okay. We just need to save it as a reference essentially and delete it later, so there's no point in knowing if it is a specific user widget. We just want to know that it is a user widget. Final two ones, we have a painting instance, and this is going to be a material instance like this, and we have a painting surface, which is going to be an actor. So the first one is going to be the material that we are going to apply to, where is it? To this plane, so that we know what we're projecting on. The painting surface is, let's say what we're going to set up later is if there's a door here, once this puzzle is solved, the door opens. So this is our way of interacting with it. We're going to put the paintings in a folder we'll call painting, so that it's a bit so that's separate from the rest, and we'll do the same here. These will be parameters because there's multiple of them, and substep and target. For this, we'll put a category for conditions, we'll call them. There we go. Put it like this and like this. Now let's work on our begin play now. So the first thing we want to do in begin play is essentially we want to make sure that our plane here, our painting so to speak, is on the surface behind us, like behind the light, so it's stuck on it, because otherwise we kind of end up with a situation where it looks a bit weird like this, for example. But in our case, actually it would already be better to modify this so we can actually line it up properly, because right now it looks a bit like a mess. So what we're going to do is essentially line trace this way, and we're going to move this to where it hits. Simple as that, nothing too complicated. So I think first what we're going to do is we're going to make our material for the plane first, because that's the first thing we want to save, even though it's not important. Let's get that out of the way first. So in puzzle, I'm going to make a new folder called materials, and we're going to need two. First one is for this, the second one is going to be used later, but for now we'll make it as well. First thing is we want a material for the UI. So this is just stylistic. It's not necessary, it doesn't help with the tutorial or anything, but while we're at it, we'll make it. So we're looking for a material we'll call m_fade. Open it up, try it here, and we want to make sure this is a user interface. So look for user interface in your material domain. If you don't have the material domain, you can click here, I believe, and it will show this kind of details panel. Blend mode, we're looking for translucent gray transmittance, and that should be everything we need. Now what we're going to get to make this is texture coordinate. Now will give us this kind of yellow, green, red gradient. We're going to add it, so I just hold A and left click. We're going to add a 2 vector, so 2 and left click as well, together. And this needs to be -0.5 and -0.5. And so if we look at the results, we get this kind of like grid. Next, we're going to mask to get only the red. So look for component mask, and we just want the red. So if we look at it now, we should just have this. There we go. We have half of the image cut off with a gradient, essentially. Then we're going to multiply this by 2. So put 2 here, or you can make a node here as well for it, but this works just fine. Look at this now. It looks pretty much the same, just a bit brighter, so less of a gradient, so to speak. And finally, we then go and multiply it by itself, so it turns into a mirror, essentially, like this, with both sides having the gradients. And finally, we're going to 1 minus it, so that it does the opposite effect, so it fades out as it goes outwards instead of fading in. And so if we plug this into our opacity override here, and just drag this a little bit up, move it to the back, and then we get from here vertex color. And so this means we can actually change it based on the tint inside of the widget. So just save this here, apply save, and we can close this one. We're not going to use it just yet, we're going to get to it in a bit. another material now. So m underscore painting this time. Double click, open it up. And so here we need a few things because we're going to have to do a bit of math to get this to work. So I'm going to start with 3 kind of different segments. So first we're going to look for a texture, not sample, I believe. Look for a texture sample. Then we're going to right click and we're going to say convert to parameter. This is going to be our mask texture. Then we're going to be looking for another one. So just copy paste this, and this will be our empty painting. And so we're just going to save these just to keep things organized by getting a named reroute. This will be our mask texture. This and another one here. So named reroute, and this will be our painting mask. Like this. So we've already imported all the assets. So what we're looking for here though is something called, I believe, T underscore UDK sky mask 03 or sky cloud mask 03. So essentially it's just something a bit blurry and in a black and white mask that we're going to use to do the transition between when we solve the puzzle. So once again, just aesthetic. You can do this a lot better than this, I'm sure, but it works. It looks okay. It looks similar to in Resident Evil. So that's what we're going for. For the empty painting, we are looking for the blank file that we called. So this one right here. And now let's do the next part. So now we're going to make a 4 vector. So hold 4 and left click. And we want to say convert to parameter, and this will be our mask tint. And I'm just going to put it red by default, because that's the color I use the most. And then we're going to look, actually before we do that, we need something else. Yeah, so sorry, before we do this, we need the multiplication of something else. We need a little thing here. So we're going to make, with our mask texture, right here, we are going to add, so a left click. We're going to add a lerp. So L left click, plug it into here. And we are looking for 3 scalar parameters here so we can modify how it works. So S, and then we're going to call it alpha. Plug this in here. Sorry, not another S, and it's going to be min alpha. And we'll duplicate it and call it max alpha. So max is at the bottom, min is at the top. Like this. Just move them a bit closer. There we go. Now you want to make sure this is 0.5 and this is 1. Next, we're going to multiply this by our painting mask. I'm not sure if we can see any results here at this point. Let's just have a look. So pretty much here what it does is you can see the kind of look of this appear over this mask, over the white area. And as we modify this, it'll be easy to see once we have a material instance, because we can then tweak the values as we go. We'll see something nice here. So we're going to multiply this again, and this time we're going to multiply it by another scalar. Sorry, no, just by alpha again. So if you name it alpha, it will copy this one. Plug this in here as well. And so now by default it should be blank, because there's no information, because this is 0. Finally, we want to clamp it between 0 and 1, as this can result in it becoming a lot brighter, and we don't want it to be like that because it is an alpha mask. So we're going to save this as a named reroute called alpha mask. Now we can do the last bit, which is here, or not the last bit, there's still a little bit left to do. So with this, we're going to multiply it by our alpha mask. So get that here, alpha mask. Plug this here. And with it, once again, we're just going to clamp so that our tint doesn't get too bright. So clamp this. Then we're going to multiply so we can actually control the intensity. So we're going to get a scalar called emissive intensity. This, plug it in. 1 by default, meaning it's just normal, nothing special. And we're going to save this as well as a named reroute called emissive. There we go. And that almost does everything. We can't just plug all of these in directly. Now we need to do one last bit, which is a if node here, which is going into base color. And you're going to get an error because there's no information. We want to get another parameter, so a T texture sample, convert to parameter, complete painting. So this is going to go into A superior to B, and it's going to go into A double equal to B. Now, if it isn't, so it's inferior, we're going to look for painting mask, like this. And I'm just going to set the default of this to be what it's supposed to be, which is dark, I called it, which is just pretty much the final version. So if our alpha mask is compared to 0.5 is what we're doing here. If it is superior or equal to 0.5, it will say complete painting. Otherwise, it will be the painting mask, aka the incomplete one. Now, what this means is that when this evolves, because we're going to be making this become brighter and brighter, it will start turning into this. Now, it also means that as it progresses, some of the parts will be already like the final color, so this gray, and some of them will be still white because they won't have been resolved yet, because we did this kind of mask-ish look to it. Now, finally, we can finish with the emissive color here. We're going to have an if statement again, so I and click, and we're going to have a second one, and this got a bit messy, so it shouldn't be too complicated, but it's not exactly clean. So look for alpha mask here, and plug it into the A on both of these. Now, if this, we want to take the first if, plug it into superior and to double equal. Then we're going to look for a one node here, so just left click with one held down. And we're going to leave it at 0. We're going to plug it into the superior and double equal and to the inferior here. We're going to plug in the emissive here. And finally, we want this to be 0.5 and this to be 0.4. Now, more or less what this does is it just kind of controls the intensity of it. So only the specific elements within here that are bright, so to speak. So if essentially the mask, if a point on the mask is superior to 0.5, then it should be black. If it is inferior, that means, let's say, we're still brightening it up. And in that case, it will appear as emissive because it's still not reached the point of 0.5 where it starts becoming a complete painting. And we also do the same thing, but in opposite here, where we keep it at below 0.4, so that not everything is like emissive, but only a specific point between 0.5 and 0.4. Now, there's probably a better way to do this, but I am really not good at materials, no matter how hard I try. So if somebody knows a better way, please let me know how you can just clamp this between 0.5 and 0.4 for the emissive. We can apply this now, and we're going to make a material instance so we can see how it works. So it's actually clear what we just did. So right click on this and create material instance, mi painting. So we're going to double click on this, and we are going to put this on a plane so we can actually see it. So there we go, that looks a bit better. And I'm just going to open it up. So we're going to set the variables that I have, and that should work just fine for everybody. So mask tint, we're going to leave this in red, no problem. Alpha, we'll leave it 0. Actually, to be fair, we could also just go into our painting back here and make sure alpha always stays between 0 and 1, because it can never really go higher than that. Or at least it shouldn't, I don't believe. Yeah, no, that's correct. So it should not. So just change this here so it's between 0 and 1. Save. And now if we move our alpha, there should be some change. So first I'm just going to change the emissive to 15, so it's a bit brighter. We're going to change this max to 0.5 and min to 1. I actually think I inverted them. So leave this at 1, this is 0.5. And we're going to swap them around in the painting. So right here, max alpha at the top, min alpha at the bottom. There we go. Apply, save. Should be no difference. But now if we start increasing the alpha, it kind of has this like effect of transitioning between the two with a bit of fire. As you can see, if you go above, it starts bugging out because it kind of goes back and forth and doesn't like that. But between 0 and 1, it really does stay into that effect. So if we like put just 1, you can see it's done. Now it does have this kind of glow on the outside now, and I couldn't figure out how to get rid of that, but it's not exactly crucial to the tutorial functioning. It's just an extra cool effect to add on top. Did I not save it correctly? Alpha. Oh, I must have misclicked and put min alpha or something else. So between 0 and 1, apply, save, close it, and now, there we go. Now it stays between 0 and 1. So this is the effect we're going to give it. So we can close that, and we can now finally start setting up all the blueprints and be done with it. So we don't need these two. We only need the begin plane. So first thing, we're going to finally be able to say plane create dynamic material instance, and we're going to use our mi underscore painting like this, and we're going to save this to the variable we made here, painting instance, alt, and let go, so it appears as a set. And so if we just do this, this won't exactly work because our plane won't take the material. So we're going to say set material to be this. There we go. Line it up. And so now if we play, we'll be able to see the material lines up just fine. There we go. Let's go back and keep going. So, sorry. The material appears as it should. Okay. Next up is we're going to do our line trace. So we're going to look for line trace by channel like this. We are going to simply line trace forward to see where we project our plane. So we'll get the spotlight, as that's going to be the direction we're facing or projecting the image in. And I'm not sure why this camera here is child that. It should be attached to this. Normally it shouldn't move it, so that's fine. Here we go. So spotlight, get world location. And we're going to plug this in to start. That's where it's going to begin. Then we're going to say plus. Plug the plus into the end. We're then going to say spotlight again. And we're going to get our forward vector. And we're going to multiply it to get a distance in front of us, or in front of the spotlight. So look for float, and we're going to say 1,500 is going to be the limit. This is up to you to choose. It's kind of just the max point at which the image can be, or the painting can be pushed onto a wall. If it's any further than that, it will just stay where it is now, aka just about there. So we want to check if we hit something first, otherwise we don't do anything. We're going to break this. We are going to save our hit actor as the painting surface. So like this. Then we're going to get the impact point. And we are going to get our painting, so our plane, sorry. And we're going to say set world location. This. And we're going to set it to our impact point. And the last thing we'll do is we will attach our plane to the actual surface. So we're going to say attach component to component like this, and the parent is simply going to be the hit component like this. So we close this, and now if we now play instead, right now as you can see it's hovering. If we play, it should appear behind, or on top of it at least. That's what it should be doing. Where did it go? Let's see if we can find it in here. So the plane seems to have worked. Because we attached it, it has scaled itself up. So I forgot, I made a little mistake. We want to make sure this here is keep world. Keep world, and we don't need to weld the bodies because it's not simulating anything. So if we play now, there we go. It appears exactly where we want it. It is now attached to the wall just fine. And that will do it for our begin play. So next, let's finish setting up our inputs. Not our inputs, sorry, our possession. So we need a few extra things beyond just this. So we're going to drag this a bit further because we're going to need this information anyway. But actually, no, we just need this for this. So this can go here. This, on the other hand, can move because we're going to do something first. So align this up here. There we go. So first thing we're going to do is, if we are in this situation, we want to show mouse cursor, as otherwise how are we going to know when we drag? So true. Next, we want to make sure we change our input mode. So set input mode to game and UI. Although in this case, to be fair, game alone would be enough because there is no UI. But usually you might have some UI elements. So let's just go with this. Now you can choose if you want to hide it when you drag. And in my case, I'd like to have it hidden. It's not a problem. But we do want to flush our inputs here. So that means if, for instance, our character is moving while we press F, it will stop the movement as well, indirectly. So plug in the pin here. And now we can finish by adding normally we would add here our UMG for the instructions. So compile and save. For now, we don't have them, so we're going to skip this little part, I think. And sorry, I completely forgot something. We're going to get our puzzle piece here. Actually, do we already do that in our interact? I think we do. In our interact, we already do this, yeah. Yep, right there. If we look in our fade to black, yeah, we make sure this is visible here. So we don't need to do it on the possession. So we don't need our puzzle piece here. So this will do it for our possession. Let's do the opposite. So we're going to look for unpossessed. So up here all at the bottom. So for unpossessed, we pretty much want to do the opposite. So we are going to look for our player controller again, or cast to player controller, like this. And we're going to do the opposite of this. So copy this, plug it in here, say false, add a reroute just so it's a bit more readable. This time we're going to set inputs game only. Now, if in your case you're using this for another project and you don't want it to just be inputs for the game but also UI, then you don't need to change this. So we're going to once again flush our inputs. We're then going to get our enhanced local player subsystem again. We're going to check if it is valid. And then this time we are going to remove the mapping context. So remove mapping context. And we're looking for our, I believe we just called it our puzzle. There we go. So is valid. There we go. Another reroute just to keep things tidy. There we go. And so finally here, we're going to remove our UI once again. So we can actually just call this here remove for now from parent. And we're also just going to say get our puzzle piece here and say set hidden in game, like this, new hidden. And so we can test this out very quickly by just going to our cancel here and saying is our previous pawn valid. So right click to convert to validated get. If it is, we're going to get our previous pawn and we're going to say possess, not add possessable, get controller, sorry. Then we're going to call possess. We're going to plug in our new pawn, or essentially the old pawn, into here. And we'll just call play sound 2D. And we're just going to say the error essentially. So we'll just say, where is it? Compile failed. So normally, if we now go up to here, we press F, we interact, we open it. And if we press tab, it closes. So, and we do have an issue here with our UI, apparently. So, oh, sorry. The reason for that is very simple, is because it never actually gets taken off when we interact. So it kind of looks a bit weird here. So if we tab again, it's still visible. It doesn't get hidden. I think I know what the issue is. The reason is because once we finish going through our, let's say we unpossess here. So we go back to possessing our character. In the character, it's still considering that something is wrong with the closest interactor. Because in here, what it's doing is it's saying it is not that and that there is no overlapped actor to actually interact with, which is not true. Essentially, what's happening is when we go into here, sorry, our, let's say when we possess something, this gets called. it says stop, not specifically this one here, but our delegate to stop overlapping all actors occurs and causes this one to be empty. And so because it's empty, none of this happens. So essentially this ends up just appearing in the center where it was and just not moving. And so we don't want that. So the way we're going to fix that is we're going to say on possession here. So I believe we have the same event. If we go down here, we have possessed. There we go. So we're just going to put this above our begin play, and we are going to say, if we possess this pawn and this is not empty, we want to make sure that our closest actor here, so our closest interactor, actually we can just do this instead, right click, convert to validated. If this is true, we're going to get to call our new closest, so call and plug closest into here, and that should resolve our issue. So if we go and play like this, F and tab, it is aligned once again. It works just as it was before. Now, on the other hand, if we solve it, we need to do something else. This will work for now. I think there is going to be an issue where if we solve the puzzle and we cannot interact with it anymore, this is gonna not be enough because we'll still end up in the same situation, but this time it won't be true. So it will not be the closest, so it won't cancel, or it won't reappear, sorry. So for now, we're going to leave it as is. We're going to come back to it once that issue occurs. So I'm going to close these two for now, and we're going to go back to our pedestal. We're going to start with our grab here. We're going to say this is going to set mouse down. Very simply. Nothing else, that's all it needs to do. Now on look, we're going to go here and say, is mouse down? Yes, if it is, we can then use the information here. So we're going to reroute this, and we're going to clamp the axis 2D so that they don't go too high or too far. Because essentially when you look, if you drag very fast, it can move very, very fast. But in our case, we're going to try and keep things as similar as possible between the WASD and the dragging with the mouse. So we're going to make sure we say -1 and 1 here. We're then going to plug this into a function, which we're going to reroute here and then right click on it to say collapse the function. We'll call the function rotate puzzle, and we're going to do that in a second once we've finished setting up all these functions outside. So for rotate, we're just going to get rotate puzzle, plug it in right here, and we're done with it. That's all it needs to do. And so that does it for everything except our interact, which is going to need a tiny little function left. We need two things. First, branch. If we have a is solved, no, it's not is solved, is valid rotation, then we're going to say custom event CE_solved. And we're going to say CE solved, like this. Then we're going to say play sound. If this isn't valid, that we try to lock in the cube even though it's not correct, we're going to play a sound to say that it's not working, and we're just going to use our trusty old compile save, failed, sorry. So there we go, this does it. We're going to move solve to the bottom, and we're going to do it very quickly because it is not too difficult. We're going to do right here, unsolved is solved becomes true, like this. And we're going to say play sound 2D again, and it is going to be success. So we have compile success right here. Then we're going to call a timeline. So TL_puzzle solved. This is just essentially to make it so that it changes the plane appearance. It's right here. So we're going to say, double click on this, and you're free to adjust this as you want. I'm going to make it 2 seconds. 2 seconds. Add a float track, and I'm going to call it alpha. And we're going to go from 0, 0 to pretty much value of 1 at 2 seconds. And that's all we need to do. So close this. And from here, we're going to do the final bit, which is we're going to get our painting instance right here. We're going to drag set scalar. Why can I not? This isn't the right type, I don't think. Okay, yeah, sorry, this is wrong. This needs to be material instance, and we're looking for dynamic. I got that wrong. So change variable type, it should work fine. Yeah. And so here we get to call set scalar parameter value like this, and just delete the other one, we don't need it. And make sure you name this exactly as it is in the material. So in our case, it is alpha. Make sure there are no extra space bars at the beginning or the end, or it won't work. So plug in the value, and this will do our final bit. One last thing we're going to do, we're going to put a little branch here and say, does our painting surface actor, does object implement the interaction interface? So BPI interaction interface. If it does, we can say interact. If not, we do nothing. So if this is true, grab it, say interact, and we want to make sure our painting surface is the target and the interactor is, interact message. There we go. Target is the painting surface and the interactor is self. There we go. So we can compile and save. That does it for this. And the last thing we need to do is our rotate puzzle. So this isn't going to be too complicated. It's just a tiny bit of math just to move the object around, essentially, to rotate it smoothly. So I'm actually going to, before we do that, we need to make sure our substep and our tolerance are set. Otherwise, they're not going to move. So for tolerance, I'm going to put 15. Now, this is a rather big number, but it's just that I can actually just show you the result without having to spend minutes trying to get it exactly right. Next is a substep. Now substep, I have it very, very, very low because it's very sensitive. So from here, we're going to get our input pin. We're going to multiply it by 1 and 0.2 because the y-axis for some reason is a lot faster than the actual x-axis. Then we are going to multiply this again. Actually, we can just do this in one go by a float. And that float is going to be our substep here divided by our world delta seconds. So like this. Move this a bit closer and plug this into the second node. Now we'll convert it to a 2D. That's fine. That's what it's supposed to do. There we go. Next, we are going to get our camera. Yeah, this one right here, or you can get the one here. That works just fine as well. And we're looking for get right vector. Now here is kind of where you can make a choice. So I'm just going to make it first and then I'm going to explain what I mean by that. So here we want make rotator from X, and we are going to multiply this, which we're going to break like this. And so X is going to go here. There we go. And then we're going to make another copy of the camera, which we're going to get here and say get up vector. And we're going to do the same thing. We're going to get make rot from X. And the same multiplication we'll do here. So multiply, I'm just going to put this at the bottom. Apparently I can't, so just like this will do. And we are going to use a combine rotators node here, and we're going to get our puzzle piece and we're going to say add world rotation, plug it into here, plug this into our execution pin, and that will do the rotation. Rather easy. Now what I meant by here is where you can make a choice is because of this right here, and also this one at the bottom. So when we're deciding when we rotate, I decided, or at least I made the decision that it is easier to manage if your rotation is aligned with the camera rather than the world space, so to speak. So I use the camera, meaning it is the right vector of the camera, the up vector of the camera. So it's relative to where you are looking from. So this won't rotate this way and this way, it will rotate this way and this way instead. So you could alternatively use the pillar instead, or you could use world space, although I wouldn't suggest world space because it depends where your object is, where it's facing, and that's probably never always going to be the same, so it'd be confusing. So you have a few options of how you want to do it. I chose the camera, you could choose the pillar, or the spotlight maybe works as well. It's up to you. So you just have to change these two from the camera to be whatever component you want. Now, next we want to check if it succeeds, if we're in the right rotation. So we want a branch, which we're going to plug into here. We are going to use our puzzle piece. We're going to get relative rotation, and we're just going to compare it to our target rotation here. And the tolerance is going to be our tolerance variable there. Our tolerance variable right here. Plug it in, line it up, and plug it into the condition. If it is true, we have a valid rotation, so true. Otherwise, it is not, false. And that does it for our rotate puzzle, essentially. So let's give this a try. I'm going to do something here. I'm going to add a event tick, or the event tick, back in. And I'm going to put a print. And with the print, we're just going to have... Actually, no, I'm going to use a print text. It's a bit easier to handle. Print text, I'm going to make sure we set it to have a key. So we're going to say rotation. And this way we can track as we move it so that we know whether it's working or not, so that we don't have to waste time. Now, first, we're going to get our controller here. And if it is valid, that means the player is currently controlling this pedestal. So then we can actually check for this. Otherwise, we're printing all the time. That's not necessary. So what we want is we want our text here to be formatted like this. And I'll drag this a bit to the side. We're going to say puzzle data. And we're going to go back to the line and we'll just use one thing, which is curly brackets with any text, and it will appear right here. We're going to look for our puzzle piece. We are going to look for relative rotation, and we're going to turn it into a string because this does not work. So we need to get string, to string should do. There we go. And plug it in here. And this is essentially all we need. Maybe not go back a line, actually. We can just do this here. There we go. So if we compile and save, if we now go and play and interact here, we have our rotation. If we drag, it turns very fast, I might add, and in both directions. If we go up, as you can see, it's not rotating directly facing the camera, and I couldn't really figure that out. It kind of has a weird angle, so I need to, maybe we can double check why that is. Maybe instead of our rotate puzzle here, if we instead use our Y, make rotation from Y instead, it might look a line nicer. Let's see. No, that does not help at all. That is not it. So let's see from Z. Z here, plug this in. Yeah, this is worse. Now it doesn't rotate. It rotates sideways when I'm going up and down. So it's twice the same thing. So we're just going to stick with make rotation from X, because that at least functions. I know it can work, even though the rotation isn't perfect. So right now, if we rotate, we're looking to make this 0 on all axes. So that means we want to rotate it so that it fits 0, essentially. That should be considered good. We press F, it succeeds, it does that, and it is essentially complete. Now if we press tab, we leave, we still have this issue. Once this is done, if this is not the case, we're going to say, we're going to just pretty much copy our, not our unpossess, but our cancel. So I'm actually going to turn this into a function here. So custom event ce underscore cancel, plug this in here, and we're going to call here cancel as well, not that, ce cancel, like this. And so that means if this is solved but we don't have anything here, we're going to call cancel, so like this. So if you resolve it now, it will kick us out. Now in the end, this took a lot longer than I thought, so I'm going to leave this part here. I'm going to make a fourth part, which is going to be pretty short, which is just going to cover adding the UI, fixing the last little bugs, and adding a door that opens once we complete the puzzle with our interact right here. So thank you for watching. Thank you to everybody once again on Patreon who has supported me, and I will see you in the next and final part, normally right after this. Goodbye.